Hey pre-algebra, so these are the notes in the lesson for lesson 14.2, which is about describing functions. If you haven't done so already, these notes are available on Google Classroom if you want to print them off and then fill them in as I'm going through the lesson. That might be a good idea. So a couple of sort of baseline things to start with. Let's remember that the graph of an equation is a line, then we have a linear equation. So that's sort of a summary statement from what we've been talking about over the course of the last week or so. When there's only one y value for each x value, then we learned yesterday that that specifically is a linear function when it also forms a line. So yesterday we talked about functions having only one y value for each x value. If that happens and it also forms a line, then we say it's a linear function, okay? The line must be non-vertical for it to qualify as not only a linear equation, but as a linear function. So for instance, we could have something that looks like this, and this purple graph would be a linear equation, but it wouldn't be a linear function, okay? So linear equation is a little bit broader, and then linear function is more specific, and that's what we're gonna look at today. For these other notes, if you wanna open up your book to page 426, I'm looking at number 2, your turn. It gives us this equation for a line, and we recognize that the y equals mx. Notice that the plus b, since b is 0, we don't write the plus b, it's just y equals mx. And the instructions here say to state whether this relationship between the x and the y is proportional or non-proportional, and then graph the function. Okay, well, we already know that this is proportional because of what we talked about back in module 12. When b is 0, which in this case it's 0, it's going to be proportional, all right? But there's other strategies to look at this as well. You're going to want to make a table and you want to choose some x values. Now, some of my hints on choosing the x values is I would generally choose something that is both positive and negative. And I would also generally try 0 as an x value, because if we do that, then we create an opportunity in our table to see what the y-intercept is. And sometimes these graphs change a little based on whether the x is positive or negative. So it's nice to have one of each to sort of test it out, okay? Once you have your x values, then you're literally just going to evaluate. And there's a couple of these on your homework where it'll give you an equation and it'll say to evaluate for the y values. So you're literally taking these x values, plugging them in, and producing y. Now the other hint on the x values is use some number sense, okay? What do I mean by this? Well, in this equation, we're taking half of x every time. So number sense wise, I'm going to pick x values that are even. It's easy to cut those in half. All right. So half of -2 is -1. Half of 0 is 0. Half of 2 is 1. And of course, now that I have those points, I can simply graph. Okay, and I'm just going to eyeball this one. In this case, x is -2, y is -1, 0, 0, and then 2, 1 is going to be about here. And when I connect those, I can see a couple things. 1, this is linear. 2, I can see it's proportional. It's crossing through that origin, okay? And 3, I can actually say that this is a function. And if you remember from yesterday's lesson, we know it's a function because it passes the vertical line test, okay? That vertical line test is going to be a great thing to check on as we're going through doing some of these, all right? Okay, so then the next thing we're going to look at today is determining whether a function is linear or not, okay? And believe it or not, if I drew something like this, or I drew something like this, or I drew something even funny looking kind of like this, okay? All of these are functions, okay? They check off as functions. And again, I can test that by running the vertical line test. These purple lines will not pass anywhere through these red graphs more than once. However, these are also non-linear functions. And obviously that's because none of them form a line. Okay? But because they are non-linear, they are automatically non-proportional. All right? And that's kind of a nice checklist thing to know. Okay? So in order for it to be proportional, we know that it must cross the origin and be linear. Okay, so I want you to kind of think about those facts as you're going through the homework today. It's sort of like you're building these checklists of what's a function, what's not a function, and then is it a linear function or a non-linear function? And then if it is a linear function, is it proportional? Okay, so, you know, if I gave you something like this, and we drew this, we would say that this is a function. It passes that vertical line test. It's linear. It makes a line. And it's non-proportional because it doesn't go through the origin. Okay, so you're looking through kind of those checklist items, all right? Okay, the next thing I want you to do is in your book, go ahead and flip over to page 428. If you need to pause this for a second, you can do that. I'm just going to go through some of these sample problems again with you. Just want to make sure you get a chance to really practice these things. So on 428, we're looking at the guided practice. Notice it says plot the ordered pairs from the table. So they're giving us our x values. Then graph the function represented by the ordered pairs and tell whether it's linear or nonlinear. So we've got a couple different things to do today, which we can certainly do. Let's start with filling out our table. I am going to rewrite this in the y equals mx plus b form. Let me zoom in just a little so we can see that better. There we go. And all that means is now I've got y equals negative 2x, there's my slope, plus 5. Now, if you were paying attention for the last month in school, we already know that this is linear because it has that rate of change, that slope, and we already know that it is non-proportional because it doesn't cross through the origin. So now we're going to justify that or prove that, okay? Let's start with negative 1. Negative 1 times negative 2 is 2, and 2 plus 5 is 7. Let's repeat that. 1 times negative 2 is negative 2. Negative 2 plus 5 is 3. 3 times negative 2 is negative 6. Negative 6 plus 5 is negative 1. And then 5 times negative 2 is negative 10. Negative 10 plus 5 is negative 5. And then we're going to go ahead and graph these points. Negative 1, 7, 1, 3, 3, negative 1, and 5, 5. Okay? And when I go through to connect this, we can very clearly see. Graph the function and tell whether the function is linear or nonlinear. We can see that this is linear. We can also see that it is non-proportional. And remember, our vertical line test tells us that this is a function. If we were to draw vertical lines through here, it would only cross the graph one time. Now let's look at this other one over here. This one's a little bit different looking. Okay, again, I'm going to do the y equals mx plus b form. So y equals, we've got negative x squared and then plus 2. But I want to point out something that looks a little different about this x value from the other x value. Notice over here we have x to what power? Well, it's to the first power. Now we have x to the second power. And I'll tell you right now that this is a dead giveaway. we are not dealing with a linear function. It might be a function, but it's not going to be linear. And let's test that out, okay? -2 squared. So what's -2 times -2? It's 4. 4 times a negative is -4. And -4 plus 2 is -2. So these are just basic PEMDAS problems from the beginning of the year. -1, we're going to square it. -1 times -1 is 1. Opposite of that is -1. 2 plus a -1 is 1. 0 squared is 0. Opposite of 0 is 0. Plus 2 is 2. Ooh, look, there's our y-intercept. Let's see what that looks like. 1 squared is 1. Opposite of 1 is -1. 2 plus -1 is 1. 2 squared is 4. 4 times -1, or sorry, 4 times -1 is -4. -4 plus 2 is -2. We're going to go in and we're going to plot these points. -2, -2, -1, 1, 0, 2, 1, 1, 2, -2. And look what we have here. We have this parabola. Okay? So a couple things. Clearly we see that this is non-linear. Okay? Because it's non-linear, it's automatically non-proportional. But it is a function because, again, it passes that vertical line test. Okay? So let's take a look down here real quick at these last few. These will be pretty quick. What did we say about when we see this exponent? We automatically know non-linear. Well, if it's non-linear, then it's also non-proportional. Okay? How about over here? Basically, can I write this in the mx plus b form and see that the x is just x to the first power? Well, we can. Right? The slope here is -1. The y-intercept is 1. So this is linear. It's just non-proportional. Okay? It will make a line. So then at the very bottom here, it says, explain how you can use a table of values, an equation, and a graph. So table of values, an equation, and a graph to determine whether a function represents proportional relationship. Well, in a table, let's see, we're looking for that it will include what set of points? It'll include 0, 0. Okay? In an equation, we are looking that it is just y equals mx. Okay, the plus b would be 0. And then in a graph, of course, we're looking that it's a line through what? Through the origin. Okay, this little summary statement here I think will be very helpful today on your homework assignments. Remember, feel free to press pause on this at any time. If you want to rewatch it a couple times, that's great. I'm also going to be posting some other practice assignments that'll go along with this that are not for a grade. It'll just be for a little bit additional practice, okay? Email me if you have any questions, and you guys will be good to go.